All right, today's talk is data partitioning. Let's roll the intro. All right, data partitioning. Why would you ever do that? That's kind of what we're going to talk about today and some of the reasons and benefits of actually doing data partitioning. Whether it be in a relational database system, could be flat files, could be a cloud service of some kind. And there's many different approaches to do that. We could use a NoSQL or not only SQL database. But let's get started taking a look at a few of the things that we have on our plate. So data partitioning. Why would you ever do that? There's a lot of reasons why companies and organizations turn to data partitioning strategies to enable their business to grow and to meet certain service level agreements, as well as for ease of maintenance and other things. So let's get started taking a look. So really what data partitioning involves is something common to humans. So humans consume and store partitioned data logically, physically, and virtually in many different ways every single day. Whether you go to the store to buy a box of donuts, it's going to typically come in a box of 6 or a dozen, or you may just buy one and put it in a bag, but you don't buy 12 and put it in a bag. There's a box. You take a dozen donuts and voila, there you go, you have it. Train cars, you don't have one huge train car filled with all of the goods that train is carrying. You break that up into multiple train cars. Same thing with time zones. We have multiple time zones throughout the world, countries, states, provinces. We even separate our networks and the internet based on network segments. We have hours, minutes, seconds, years, etc., many different ways to partition data. And let's get started now that we've kind of got that abstract concept of partitioning data and why we do it. So when does it make sense in database systems? That's all going to depend on really your organization and how you access and utilize and store, as well as what type of data it is that you're actually storing in that system. And there's multiple different ways. Today we're only going to really look at data partitioning in a horizontal fashion, just as a sample to get you started with the concepts. So when your data consumption or collection of that data becomes inefficient and impacts your business processes and costs, that's when it's really beneficial to start taking a look at the option of partitioning your data, whether it be functionally or taking transactional data and partitioning it horizontally, or even in other cases, sometimes vertically. If you don't do it, you tend to allow yourself to have more bugs in your code and with your systems. It increases fragility as your business grows and grows and that data set becomes larger. When partitioning data, you will run into challenges. Not all of them they're not overcomable. And they're really not as bad as they seem. However, if you've never done data partitioning before, it may be a little bit of an apprehension about how horrible these challenges are going to be. But rest assured, if you do it the right way, these challenges are very minimal. So what benefits will you see from data partitioning, whether it be functional or if you're partitioning data horizontally on transactional type of records, log records, etc.? You'll see a lot of benefits. So some of the benefits you'll see really center around locking contention reductions, faster index performance on create, read, updates, faster backups and maintenance processes, more flexible disk and I/O optimization strategies. You can distribute your load across multiple platters, across multiple servers, even across multiple networks if you really wanted to get to the extreme. You could have some on-prem, some data in the cloud. There's a lot of things that you can do with partitioning that really allow you to scale out rather than simply scale up in one single database. You're going to see faster overall CRUD performance in the case of relational database systems. That locking contention and the faster index performance, less impact of maintenance processes and reporting being done only on multiple small shards is going to increase your overall user experience with CRUD performance across everything. So you're going to see reduced load on the server as a result of that, because each query is completing, so you have fewer queries executing at the same time. You're going to have manageable change detection of individual rows being changed or being inserted. When you have a new row being inserted, you have new records that maybe need to be reported on. You can do that across each partition and keep data in sync much faster. Reprocessing of large transactional queries and reporting. That's going to make it a whole lot easier to target just to the particular shards or partitions that you're interested in, freeing you from going across an entire large data set. Jobs and queries become more manageable. You can target them as needed. You can look for one box of donuts versus a huge bag or dump truck full of donuts. Multi-threading of queries becomes trivial. So that allows you to query multiple partitions across multiple servers all at the same time and take those results and stitch them back together into your result set that you're actually trying to achieve. The other benefit that you'll notice is it forces architectural adherence to doing well-structured queries as well as defining your data up front, because you do want to determine the best possible usage of your data. It enables consumption based on performance gains. Nearly limitless scalability options as well. You're scaling out rather than scaling up. So the results may vary. So for this exercise, I've gone through and tried to identify a few mock tests with some sample data that I generated that essentially is going to query across 8 days worth of data. Each day has 800,000 rows in it, and they are completely randomly generated. With the same formats. You're going to see that I also have a control table with 8 days worth of data all in one table. And then we're going to run so that we don't have just a single run being affected by my CPU performance. We're going to run that across 10 iterations, both on the individual days as well as the entire control set. And so here are some of the results that I've got. Let's go ahead and actually just do a run through just to make sure that we're getting similar results. We'll bring over another set. We're going to run all of these, and I will be back in just a moment or two because this is going to take probably 2 minutes to run all of these, and you don't want to sit here and watch my computer spin. All right, so now that this is actually completed, let's take a look and just verify that it looks fairly similar to what we have on our slides. So this is our data, 17 columns, typical business data. It's very pedestrian. There's very little indexing on this as well. I indexed by last name, which is going to be part of all of our queries, as well as NABP, which is just another field here that we don't use for that. There are 6.4 million records in the 8 days worth of tables spread over the 8 days, so 800,000 records in each table. The control table has 6.4 million records. We're going to do 10 iterations, which will equal 64 million rows that we're scanning over, retrieving data for. It's not actually going to be equivalent in performance as looking over 64 million rows, of course. But this is just, again, kind of give us an idea of what data that we have and how it's configured. So we did do counts earlier against this, so we can test against all of our dates. And yes, we will have 6.4 million records if we sum them all up. And we will also have 6.4 million records in our control table. There you go. All right, let's look at our tests real quick. All right, so this one here is looking across the 8 days. This is across the individual shards. We're running it with the date parameter and without. And it just goes across the 10 times and runs that query over and over. We also execute against a single shard 10 times. And this just goes through the entire day and pulls back all the dates, or all the members with the last name Flowers, or Flower, or whatever. And then we do the same on our control table. We look for just last name and then last name and date 10 times over. And there you go. That's how we get it. Back to our tests. Let's go back to the slide here. So the thing to note here, we have these queries running in parallel. They're exporting out as CSV. We run 4 parallel threads 10 times with no compression out to CSV. It takes 7 seconds. The similar one, which just pulls it up into memory as a collection of rows, takes 6 seconds. And you'll notice all of these typically, depending on the compression level, these are pretty close, 6 and 7. So it takes about 6 seconds to get that data if we go across all 8 days to pull back anybody with the last name Flowers. Now compare that to what it takes if we had our control table. We just looked across the entire set of 6.4 million records by last name. It's going to take us 10 seconds. So there is a performance gain, although I will say it doesn't seem like a huge number. But then again, we're only looking at 8 days, and the table's fairly thin. So if you had a wider table, your performance may vary based on that. Your indexing will impact it, performance of the server, etc., etc. There's a lot of impact that really can take place based on your current environment. So let's look at the next slide, which highlights the query across partition data by last name and date range. And we're only looking for records in 2 of those 8 days. So when we do that 4 times, and just as a note, this one looks at all 8 days and only finds the records in 2 of those 8 days. It takes 3 seconds when we're multi-threading, doing it 4 threads, 10 times. Same query with the date range, looking at just the control table, 12 seconds. So it's significantly better performance when we're searching by date. That is to be expected since we don't have any indexing on date. And then finally, we do a single shard by last name for 1 day. And that takes 1 second. So the reason we do that is because if we're only searching for 2 days on these ones above, and we are going to search 2 days down here below, we would just execute this 2 times. So that gives us 2 seconds to search 2 shards to get 1 day of data each, targeted, of course, to those dates that we want to look at. By last name, it is significantly faster, 6 times faster than what it takes to actually look across the control table. So let's move on to talk a little bit about scaling this out. So imagine instead of 8 days, you had 80 days, which really isn't a lot of time. It's less than 3 months. So if we're searching values within 2 days that are sharded, you'll run 2 queries against 2 days. Each query takes 1 to 2 seconds, a total of 1 to 4 seconds, depending on the number of threads. And a thing of note is the performance is not impacted by scaling out. So you could search for 4 days. You could run 4 queries, and you know the time's going to just be essentially linear. You can account for what amount of time it's going to actually take to return that data based on how much data you're storing and how you have your partitions. If you're searching values within 2 days of non-sharded data, you can only run 1 query effectively at one time. That query will fall somewhere within a degrading nonlinear performance range. The more you scale up, it's going to take a lot longer. So if we took the 8-day amount of time as 12 seconds and the 80-day, which would be 120 seconds, it's going to fall somewhere in between there, depending on how, like I said, your environment's set up, how you have your indexing and all that. But you get the idea. It's going to take significantly longer. So instead, imagine you, instead of 8 or 80 days, you had 800 days, which is less than 3 years, which is not a long time in regards to enterprises and organizations' data storage needs. In summary, if you wanted to learn more, Microsoft does have some best practices on their documentation site. These strategies apply to anything, whether it be flat files or Mongo or SQL Server, Oracle, MySQL, PostgreSQL. It really doesn't matter. These are strategies of a conceptual nature, more of the abstract, that if you apply these in your organization, you'll notice significant increases in the ability to scale out and to better serve your customers and to better serve yourself in being able to manage your systems. Oh yeah, and don't forget, if you do like this video, or if you have questions or feedback, just reach out, get in touch with me, make sure you like. Thanks.